Hello, I welcome you all to this class. Now we are going to learn about perfect frame. That topic name is the analysis of perfect frame. So first of all, we need to know what is frame, okay, and how many type of frame and what are the uses of a frame, right? So frame is nothing but it is a structural member, you can say, which is made up of the several bars, right, or several rod also, or several element, right. And how they are connected by a simple riveted joint or by the welded joint, right. So but in some cases that these riveted or welded joint is assumed like a hinged joint, right. So now what we'll do, that you can say the frame is a structural member which is made up of the several bar, and these are connected by the welded or riveted joints. So now you can write on this, you can define them, then we'll move to the further, that it is a frame is a structural member, right, which is made up of several bar, right, joined by rivet or weld or by welded, right. But these riveted or welded joint are assumed like a hinged joint, right. Now so what are the uses of you can say of a frame? So uses, we can say that we are using this in a bridge, right, in your bridges, right, and in the roof structure which used to carry the load, roof structure, right. Also in pylons, right. Now the best example of your frame or truss, you can say the example is what, that Eiffel Tower, is it or not? Now we can say why we are using the frame, right. So with that we are using the frame for in bridge or roof structure, so to carry the load, right, and these because of their high carrying load capacities, right. Now we can say that types of frame, that how the frame is look like. The frame is nothing but any structure, that triangular element, right, is a simplest form of the frame, you can say. So that simple triangle like this triangle, right, the name of the triangle, let's say this is A, B and C. So this is the example of the frame. So it is nothing but the one frame, you can say, right, where this AB, BC and AC, these are the member. So this we can say that AB comma BC AC are members, right, and the A, B, C are the joint, right. So it means that these are the simple form of a structure. So these are connected at this point, and these are connected at this point. They are connected either by means of the rivet joint or by the welded joint, but they supposed like a hinged, right. Now we can see how many types of frame we have. Basically the frame we can classify into two types. Either the frame will be the perfect frame or it will be the imperfect frame. So how can you say that whether the frame is a perfect or frame is a imperfect, right? So let's say that here only, yes, just wait, that you can write, make a heading, that types of frame, right, that is types of frame. So types of frame, basically we can classify them into two types. That is, first one is the perfect one and the second is the imperfect. First frame is the perfect frame and the second frame is the imperfect frame. Right, imperfect frame. Now, what is the perfect frame and what is the imperfect frame? One by one, we'll discuss this. So, for perfect frame, it is what? That the perfect frame is one in which the number of members and the number of joint are given. If you see this example, that is this triangular element we have taken and we call it as a one frame, right? So now in this, how many member is there? That 1, 2, 3, AB, BC and AC, these are the three members and the three joint is there. It means that the member and the member and joint are specified, right? So such type of frame we call it as a perfect frame. Or in another way you can define that the frame which is made up of member just sufficient to keep it in the equilibrium, right, when the load is active. So means any member, you can say the simplest frame. Perfect frame is what? That in simple language, in simple way you can define the perfect frame as a, just hold on, there is, yes. So first you can make a subheading, that is perfect frame. Perfect frame, right? So perfect frame is what? In which the number of members and number of joints are specified or given. So you can say the frame in which what? Number of members, member and number of joint are specified, right? Means it is already given. So that frame we call it as a perfect frame. Or another way you can say the frame which is made up of the member to keep it in the equilibrium, right? So that frame is also we call it as a perfect frame. Now the mathematical way you can analyze that, or you can say whether the frame is a perfect or imperfect. So that mathematical relation we have. On behalf of that relation also you can categorize them, either the frame is a perfect or imperfect. What is that mathematical equation? We will see now. Just wait. So here you can see one equation I am going to write here, right? That equation will define whether your frame is a perfect or imperfect. So the equation is this, that is n is equal to 2j minus 3, right? So this is the equation on behalf of which you can say whether your frame is a perfect or not. So any frame which satisfy this equation, right, that frame we call it as a the perfect frame. Means satisfy means what? That satisfy means the right hand side, left hand side and right hand side should be equal. That is the satisfaction of that equation. So let's say that one example, the example which I have taken just now. Let's one simple triangle you have, right? We call it as a frame and we can name this A, B and C. How many member is there? That member is 3, that you can say the number of member is equal to 3. And how many joint we have? That joint is also 3 at this point, at this and at this. Is it or not? So you can say the number of joint. That number of joint is how much? How many? 3. Right. Let's satisfy this equation, that n is nothing but your number of members and j is the number of joint. So you can write where n is the number of element or member also you can say. Most of the time we call the member only, number of member, and j is the number of joint, right? So if for this example, if I take this condition that n is equal to 3 and j is equal to 3. So what is the equation? That n is equal to 3 and j is 3, that is 2 into 3, right, minus 3. How much? That is 3 is equal to 3. So it means this says that this member, this frame satisfy this equation. So this frame you call it as a perfect frame, right? This equation, this frame you call it as a perfect frame. So perfect frame is one which satisfy the equation n is equal to 2j minus 3 is known as the perfect frame, or you can say the in which the number of member and number of joint are given, or you can say that the which is made up of just sufficient to keep it in the equilibrium when the load is active, right, without changing their shape and sizes, right? Now so that we call it as, that frame we call it as a perfect frame. Now one more example we can say that, let's say you have a same frame is there. So this is your one member, let's say this is the A, B and C, right? Now so this is the one triangular element, that triangular frame is there. What I'll do, that I'll take one joint here, right, that give the name of the joint is D, okay, and the join this C to D with member CD, okay, and also this and this joint D is connected by one member at B, right? So this is also, you can say this is also an example of the perfect frame. How it is, we can say how many member you have now, that is this AB, BC, AC and AD, is it or not? So 1, 2, 3, 4, 5 and 4 is 4 joint is there right now. Yes. So now you can say this is one member, this is another member, this is another member, this is another member, this is another member. So now you have a number of member is equal to what? 5, which is AB, BC, AC, AD, CD and BD, right? And the number of joint is equal to how many? That you can see here, that this is one of the joint, this is another joint, this is another joint and this is the another joint. It means that 4 joint you have. So number of joint is equal to 4, right? Means substitute this condition into that given equation, means what are the equation which says whether the frame is perfect or not. So what is the equation we need to satisfy? That n is equal to 2j minus 3, is it or not? Let's say that n is equal to how much? 5 is equal to 2, joint is 4 and minus 3, 4 2 is 8, minus 3 is the, we can say 5 is equal to 5. It means this frame is also satisfied that equation. So you can say this is your one of the perfect frame, is it or not? So this is the perfect frame. So this is how we come to know that the frame is a perfect or not. Next we have a imperfect frame, right? So imperfect frame is one in which neither the number of members or number of joint are specified. That frame we call it as a imperfect frame. So here you'll come just, yes. So now we can say the second type of frame we are going to see, that is the imperfect frame. Write on here, that is imperfect frame, right? Imperfect frame. So imperfect frame is what? In which neither the number of member nor the number of joint are given. So that frame we call it as a imperfect frame. So you can write it here, the frame in which number of members, member and number of joints are not specified, right? Or you can say are not given, is it or not? Those frame we call it as a imperfect frame. So for that same way, you can say that equation we know to know the whether the frame is perfect or not, that n is equal to 2j minus 3. It means that for imperfect frame, this equation does not satisfy, right? So n does not equal to 2j minus 3. If such frame is given in which the number of member and number of joint are not equal, those frame we call it as a imperfect frame. So imperfect frame, further it is classified into two types. That will be, it will be the deficient frame and the redundant frame. It means what? That whenever the n does not equal to 2j minus 3, the two things can be happen. Means what? That either it will be more than 2j minus 3 or it will be less than 2j minus 3, right? So on behalf of that, you can say the imperfect frame is of two types, right? Now, so now here or here only I can write that imperfect frame is of two type, right? That is deficient frame, you can write frame also, and second one is the redundant frame, right? Redundant frame. So first we'll see the deficient frame, right? So first you can make subheading, that is deficient frame. Okay, deficient frame. So deficient frame is one in which n, that is number of member, is less than 2j minus 3, right? So if such frame will come into play, that frame we call it as a deficient frame. Means what? The number of member will always less than the 2j minus 3. So that frame we call it as a deficient frame. And for redundant frame, you can say redundant frame, right? Redundant frame means what? That means in which, so you can write here, in which what? N is greater than 2j minus 3. So if such condition will satisfy, we call it as a redundant frame, right? Now, so two types of frame we classified into two types, that is perfect and imperfect. Perfect means that number of members and number of joint, that is number of member and joint are specified, or that frame which satisfy the n is equal to 2j minus 3. And the imperfect frame is one in which the number of member and joint are not specified, as well as the n does not equal to 2j minus 3. It means that either the n will be less than 2j minus 3 or greater than 2j minus 3. If it is less than, it will be the deficient, and if it is greater than, it will be the redundant frame, right? Now there are some assumption we need to see for the forces in the member of a perfect frame. So you can write next, there are the three assumption only, right? So we can write here that yes, assumption for forces in the member of perfect frame, for forces in the member of perfect frame, right? So what are the perfect frame? All right, now we will see what are the assumption in case of the perfect frame. So first assumption, you can write it here, that first assumption is nothing but all the members are pin joint, right? Means that as we define the frame is what? That is a structural member which is connected by number of members, right, by means of the welded or riveted joint. But those welded and riveted joint, we consider it as a hinged, right? So all members are pin joint. The first assumption is that all the members are pin joint, right? Are pin joint. Second assumption is what? That second assumption is the frame is a perfect one. That imperfect frame we don't have. The frame is a the frame is a perfect frame. It is a perfect, means what? N is equal to 2j minus 3. And the third is that the weight of the member is negligible, means we are not considering the weight of the member, means by which the frame is made up, right? So we can say the weight of the member, is negligible, right? Is negligible. Okay, so these are the three assumption for forces in the member of perfect frame, that the members are pin joint. Second one is the frame is a perfect, and the third is the weight of the member is negligible. It's very simple, right? So next we will see that what are the reaction supports, means how many supports is there. So the two types of support can be on the frame, that is either the support will be the roller support or it is the hinged support, right? So we'll see what is the, if the roller support is there, it means that the reaction will be the what? The reaction will be the in the direction of the load applied. Okay, and if the support is a hinged, if the support is a hinged, it means that that is the two types of weight. So now see, that is the two types of support we have, that either the support will be the roller support or the hinged support. Okay, in case of the hinged support, the reaction will be the in the direction of the load applied, right? If it is the load is vertical, reaction will be vertical. If it is the horizontal, the reaction will be horizontal, right? And in the second case, that if the support is a hinged, so in case of the hinged support, in case of the roller support, the reaction will be always right angle, right? So you can say the reaction of support of frame. So here you can write reaction, this is Rxn is the reaction of support of frame, right? Supports of frames. So there are the two types of reaction we have. One is the, that is two types of support, that first support is the roller support. How it looks like? It will look like this. These are the roller, right? These are the roller. So this is the symbolic representation for the roller support. So in case of the roller support, the line of action of the reaction will be the right angle. Means what? The reaction will always act normal, means at right angle, 90 degrees. Is it or not? Now, if the support is like this, so you can say, if the support is like this is the roller, right? So how the line of action of the reaction? It will be right angle, means it is 90 degree. Is it or not? For roller support, the line of action of the reaction will be right angle. Second support you have that is the hinged, right? Hinged support. So hinged supports, right? So if it is the hinged support, so how the symbol for that? This is the hinged support. So in case of the hinged support, it's not, the line of action of the reaction will depends on the applied load, right? If it is the horizontal, the reaction will be horizontal. If it is vertical, the reaction will be vertical. Is it or not? Now, so then in this case, means in hinged support you can say the reaction can be horizontal or vertical, right? Or both. But in roller support, the reaction will be only one. It is vertical only. Right now that is right angle, not vertical, means right angle. Now we will see whatever we have discussed so far. These are the just fundamental about the analysis of frame, right? That is for truss, right? So now we will see one simple example, and then that we have to find out the forces in the member. That see the basic things is that there are the two methods by which you can solve the problem. There is the method of joint and method of section. So we can see that first the the method to find out the forces in the frame. You can write this heading, no problem. Or just make a note, no, not will go, means need not to write any subheading or anything. So just make a note, the two methods are used right to find the forces in a member, right, in a member. Those two methods are what? That first one, you have a method of joint, okay, and the second method is nothing but the method of section. The second method is the method of section. So by two way you can simplify the truss problem, or the you can do the analysis of a frame, that method of joint and method of section. First of all, we are going to learn that method of joint, right? So for method of joint, to know means we will use the equilibrium condition. So three equilibrium condition you know, right? So in method of joint, what we are doing, that first you can write, that is method of joint, right? So what we are doing in the method of joint, that is this, every joint is treated as a free body in equilibrium, right? And then that perfect frame, that body is in the equilibrium, means it satisfies the three condition of equilibrium. Summation of V means sum of all vertical forces is 0, summation of H all horizontal forces is 0, and summation of M is equal to 0, right? So the unknown forces we have to find out in truss members. So for finding the unknown forces, we are using the two things, that is summation of V is equal to 0 and summation of H is equal to 0. You already know about this, right? That is while you're finding the resultant of forces in the first chapter of coplanar forces and concurrent system of, that is system of forces, right? Now so these things, that method of joint, we will learn with help of the one simple example. So that question is on the screen, please you copy that. See, find the forces in the member AB, AC and BC of the truss. The member is given this, that is, this is A, B and C. This BC length is given 5 meter, and at the A, one vertical load which is downward of having magnitude is 20 kilonewton is acting, right? So what we need to do, that we have to, and means we have to find out the forces in the member AB, BC and AC. So for finding these forces in the member AB, BC and AC, we will use the method of joint, right? So first of all, we need to know that where this vertical force is acting from the B, right? So first what we will do, that we can simplify this problem. If you want to check whether this frame is perfect or not, you can apply the n is equal to 2j minus 3. Just now we have did, so we don't waste the time. But if any problem will come in your paper, right, whenever you are writing the exam, so that time if you want to know, you can check by using the n is equal to 2j minus 3. Okay, so most of the problem, whatever the problem will come, not most of that problem will be for from perfect frame only. Okay, now so here we have a solution. Okay, now so first of all, let's say this is a or you can write this again. Okay, so this is your 60 degree, this is the 30 degree. These are given in the question. This is not given here, it is actually, it is provided in the question, right? So this is 30 degree, this length is 5 meter, right? And here one load is acting whose magnitude is 20 kilonewton. This is A, B and C. So the supports are acting at B and C, right? So this support, let's say this is RB and this is the RC. Okay, now so as this is 60, this is 30, so this A will be master 90 degrees. Okay, now so first of all, we want to know that where this load B is acting here on BC from B. right? So for that we need to know the AB distance, that is AB length, right? So how we know the AB? That just imagine this is one triangle, just not imagine, it is triangle. So this is 60 degree, so this will be your adjacent and this is your hypotenuse. We want to know the AB length, right? So that is cos theta, you can say cos 60 degree is equal to adjacent by hypotenuse, that is AB by BC. So AB is equal to what? AB is equal to BC times of cos 60, which is nothing but BC is 5 meter, it is given in the question. Cos 60 is half, that is AB is equal to, we got the half means 2.5 meter. Okay, now so this AB length is 2.5 we got. Now so for that, where this load is acting from? B, right? So for that we can say it is what? AB cos 60, the distance of the distance of line of action of B, right, of 20 kilonewton force from B, right, from B. Means in this frame the 20 kilonewton load is acting where? From B on this, right? So it will be nothing but, you have a what? That is the component of AB. That component of AB is what? AB cos 60, that is horizontal component. So you know that how to find the horizontal and vertical component is simple. We can say the coordinate geometry actually, right, which you have learned in your 9th class. So that AB cos 60 means AB is 2.5 into half, again it is 1.25 meter. It means here we can show from this point, from B, it is acting at a distance of 1.25 meter, right? So it is not required, just I'll show you that here the 20 kilonewton load will act. Is it or not? Now, so to know this member forces in the member, we will use the method of joint. Method of joint means what? The each joint we will take. First of all, we will take the joint where the load is specified. So first we need to find out the reaction at B and C, right? So how to find the reaction at B and C? Let's say that, just wait, it's a hardly more 3 to 4 minutes class is there, right? So we are finding the reaction at B and C, that RB plus RC is equal to 20. This is equation 1, right? So we have just summation B is equal to 0 we did. Next what we need to do, that, sorry, this is your, right, so RB plus RC is equal to 20. Now we'll take the moment about B, or you can take moment about C also, no problem. So I'm taking the moment about B, right? So then you can write that taking moment about where? About B. So when you take the moment about B means RC into 5 is equal to what? Is equal to 20 into 1.25. Why? Because 20 is acting at a distance of 1.25 from the B. So RC is equal to 20 into 1.25 by 5. So 5 4s are this. So RC we got. So let me check whether, yes. So 1.25 into 4, it is 5 meter. 5 Newton. RC we got, and RB plus RC is equal to 20. It means RB is equal to 15 Newton. So we got the reaction at the two supports, right? Now after finding the reaction, we will take the joint. So we will take the first joint B will take, right? So you can say that joint B. How the joint B is look like, I'll show you, that you can see joint B. this on this joint B, the reaction is acting vertically up, and this is one member AB and BC, right? So this vertical force is acting upward. So in this this member will apply the force which pushes this right now. So in this we have this direction, that is towards B, the force will act, and in this member BC, that force will act away from the B. That means in this member the tensile force will act, and in this the compressive will act, right? That you know from the Newton's third law of motion, that to every action there is equal and opposite reaction. Now, so first we have taken the joint B, so we'll draw the joint B, how it look like. So joint B is this one, this is your reaction, and this is the member BC, and this is the, yes, so this is your B, right, and this is your C, and this is the A, right? So as I told you, this is 60 degree. Okay, now so in this the compressive force will act, that is this member will push this reaction, right? So this, let's say this magnitude is F1, and this is the tensile force which is F2. Now we need to equilibrium condition we have to satisfy, means what? Summation V0 and summation H is equal to 0. So write down fast that summation of V is equal to 0, means this force is vertically upward and its vertical component of AB is what? F1 sine 60, right? So that you can say this is your RB, right? So RB is equal to F1 sine 60. RB we already calculated, so F1 is equal to what? RB by sine 60, RB by sine 60, which is, RB is how much? 15 by sine 60. So let's do this calculation. F1 is equal to 17.32 Newton we got. Now we need to write down another equilibrium condition, that summation of H is equal to 0. So what is the summation of H? That is its vertical horizontal component which goes this side towards left, and its horizontal component which is already horizontal force which is acting already towards the right. So we can say F2 is equal to F1 cos 60 right now. So that is F2 is equal to F1 cos 60. We already calculated the F1, so F2 is equal to 17.32 cos 60 is half, which is 8.86 Newton, right? F2. So now you need to mention the direction, that is how it is. So this is the compressive, let's say this is C, compressive is C, and this is the tensile, that is the T, right? One more joint is there, that means you already calculated the forces in the member, what? This is the forces in member AB, right? And this is the forces in the member BC, right? Now one more force is there we have to calculate, which is the AC. So just wait, that for that we will go to the joint C. So write down here that joint C, right? So how the joint C is look like? This is your C, the reaction is acting RC, right? And this member will be like this, is it or not? Yes. And this is the like this is 30 degree, it is given, and this is the RC, right? So this will be same, that is tensile F2 only. Why? Because this member is that which is connected by B only, and this is A, right? So but in this the forces, as this reaction will act vertically upward, so it will push, right? When it is pushing, it means that this is the compressive. Let's say this magnitude is F3 and this is F2. Why? Because this F2 is connected by that F2, then it's become like this triangle, is it or not? Now so again we can say the equilibrium condition, that summation of V is equal to 0. What is that V? That RC, it is acting vertically upward, and its vertical component is what? F3 sine 30 degree, right? So F3 is equal to RC by sine 30. Sine 30 is what? Half, and RC value we have calculated. RC is 5. So this is 5 by sine 30 degrees, which means F3 is equal to 10, right? 10 Newton. So this is the compressive. So now in all three members we got that forces that we can summarize them here, right? That is forces in member AB, right? Forces in member AB is equal to what? Which is nothing but the F1. In BC it is F2, and AC it is the F3. So F1 we calculated at the beginning itself, which is 17.32 Newton, and it is the compressive, right? F2 we calculated, which is the 8.86 Newton, it is tensile, and F3 just now we have calculated, this is 10 Newton, this is also compressive. So this is how we can do the analysis, and we'll find out the forces in a given truss member, right? In the next class we will discuss some more problem, the problem which is related to the simply supported truss and the cantilever truss. So for that, you please like, subscribe, comment and share this channel. Thank you.